quizzical mind, somebody that likes to solve puzzles.
Someone who can work within a team.
I think you have to be quite meticulous.
You have to persevere.
Intelligent enough to understand the logic of the code.
Have empathy for their users.
The first thing is patience.
Likes to solve riddles.
A good coder is someone who can think through clearly and implement their idea into code.
10 years ago, we were coding for computers, but now everything is a computer.
A lot of the redundant and rudimentary stuff we do as a developer will be taken over by these automated processes.
Things like human brain interfaces and machine learning and neural networks.
Potentially a new language that doesn't even exist yet.
I still believe we have a bright future despite self-driving cars and artificial intelligence.
Interacting with a keyboard-less layout.
I think we're going to see a lot more voice interaction with devices.
Hopefully not computers coding themselves. This would be like, how it's called, the singularity, right?
I code because I love coding.
I code because I love, for me, it's like a brain puzzle.
Because I'm a builder and I ran out of Lego bricks.
There's a lot of creative juices that flow when I write code.
Because I like making things, basically.
Coding is fun.
It's a fascinating, wide open field where you can do anything you absolutely want to do.
Having a problem that you turn into a solution through code is one of the most beautiful things in a job that I can imagine doing.
The great innovator, the great technologist, the great architect and developer, Leonardo da Vinci once said, "It had long since come to my attention that people of accomplishment rarely sat back and let things happen to them. They went out and happened to things." How many of you today are adventurers and explorers? How many are innovators and dreamers? How many get out and make things happen? I hazard to guess that given the work we do as developers, we are all, to a large degree, a bit of each of them. Like Leonardo da Vinci says, we get out there and happen to things. The world of technology is one of constant change, growth, and disruption. To trace back to the root of technology today, we would have to go back before Elon Musk, Albert Einstein, before the great minds like Alan Turing and Ada Lovelace, and in fact, even before Leonardo da Vinci. See, technology and innovation in many forms has been a part of human existence since the beginning. So we today are a part of a profession, a mindset, and a yearning, and a living with a long history and with an incredible opportunity ahead. As we look to the current pandemic, which is impacting so many people in devastating ways, and I feel and want to respect each of you in this room, we must also look at the incredibly rapid development of vaccines that just years ago would not have been possible. Indeed, these vaccines are only possible through the combination of many technologies from disparate disciplines at the hands of incredible, innovative, and passionate developers, none the least of whom is Jennifer Doudna, a biochemist. And we have this same capability in this room today. Like technology, development now spans realms: electronics, mechanics, biochemistry, physics, to name but a few. You see, innovation and growth, it's rarely in isolation. It builds on ideas and builds on dreams. My name is Alistair Green. I'm a technologist, an innovator, an adventurer, a competitor, and a dreamer. I, like many of you, love to make things happen and thrive on the challenge of innovation and change. My experience spans many industries, geographies, technologies, and roles. I'm a citizen developer and a business disruptor. My passion in business is to solve the most complex business problems through the use of advanced technologies and working with the industry's foremost experts. And this is why I came to Oracle. In Oracle, I lead a team of 550 cloud engineers from China to New Zealand and Japan to Australia, whose focus is to enable our customers' outcomes and help solve their business challenges in the cloud. In the short time we have today, I would like to share some of my passion for Oracle. First, I will overview what we call OCI. Secondly, I will draw the link of why OCI is the platform for programmable hyperscale cloud. And thirdly, I will share what OCI offers for innovators, adventurers, explorers, and dreamers for people like you who, in the words of Da Vinci, happen to things. So what is OCI? Oracle Cloud Infrastructure is a second-generation cloud that offers the equivalent of on-premise high-performance computing power to run cloud-native and enterprise workloads. Whether you work at a startup, small to medium business, or an enterprise, OCI can help you. OCI has a leaf and spine network design and offers very high speed and low latency to your workloads. Unlike first-generation clouds, where the network and I/O virtualization are in the hypervisors, the second-generation clouds offer off-box virtualization, meaning network and I/O is outside the box. Hence, they offer maximum isolation, which minimizes noisy neighbors, and protection or security. As expected with a second-generation cloud, OCI offers SLAs around service availability, performance, and manageability. These SLAs are important while building modern applications that auto-scale is required for the business need. So OCI lets you build from the ground up while providing the security you need and the best of all Oracle has to offer. But I'll talk about this a bit more. Put simply, OCI offers scalability and elasticity across core services, security across all layers, and can be run either on the Oracle Cloud, a specific instance for a customer, or as a dedicated region. In fact, today we have 29 cloud regions globally and a further 9 planned for the near future. 6 of these regions are Azure Interconnect regions. So very soon we'll have 38 cloud regions, excluding cloud at customer and dedicated regions. This shows the scale of OCI and should give you very high confidence as a developer. So let's look at what makes OCI a programmable hyperscale cloud. The application engineering landscape today is very broad, and we can categorize it in 3 areas: the core infrastructural constructs, the application infrastructure, and the application itself. Programming the core infrastructure is about programming your network, your compute, your storage, and security. Adopting a cloud-like infrastructure that adheres to software-defined infrastructure, SDI principles, makes its programming easier. Application infrastructure is all about programming your database, your messaging backbones, your APIs, and the images, either compute or containers. Here, the vendors of each component provide the SDK or appropriate API to program such application-specific constructs. The final component is the application itself, which consists of the user interface, the business logic, and the persistence mechanisms. The applications can range from traditional monoliths to modern application designs like microservices and serverless architecture to low-code or no-code. All 3 of these components produce its own code base, its own way to build, its own way to test, and its own way to deploy in respective sequence, according to the deployment topology. The combination of these 3 components necessitates sophisticated CI/CD tooling, along with a comprehensive observability framework to cover all aspects of DevOps. In continuous integration and continuous delivery, CI/CD, the source control system holds the code bases like infrastructure code, application configuration, and application code. Next comes the infrastructure automation that is achieved by widely adopted tooling like Terraform and Ansible. Thirdly is testing, as part of the build and release management process that results in a deployable artifact. Once the application is deployed, all 3 areas, the core and the application infrastructure and the application itself, need to be monitored, and hence the 5th element of observability. Observability includes 3 pillars, namely monitoring, logging, and tracing. Monitoring is the collecting, processing, aggregating, and displaying of real-time quantitative data about a system. For example, the latency, traffic, errors, and saturation, which are often called the 4 golden signals of monitoring. Logging then creates a central store of events that aids in the identification of root causes, and tracing is figuring out where in a system the problem happens. OCI provides tools for each of these 5 components. OCI also supports a variety of application and runtime needs, all the way from infrastructure as a service through platform as a service, containers, serverless, visual and low-code deployments. We provide tools, some of which I will outline shortly, for each of these needs. And this is why we say OCI is the programmable hyperscale cloud. Let's look at a couple of these tools. If you are a citizen developer like myself, you might be looking to program with low code. Oracle Apex is one such framework used to build desktop and mobile applications. It enables you to design, develop, and deploy beautiful, responsive API and database-driven applications very quickly. You can quickly build reports, forms, charts, calendars, etc. on top of your data in your database. Both IT developers and citizen developers who know a little SQL can rapidly build enterprise apps in only a few hours, offering you fast time to value. These apps can also easily iterate with changing and evolving business needs. Similarly, you can be equally productive with IaaS, PaaS, and cloud-native types of applications. In IaaS, you can build your own VM or VMware farm. In PaaS, you can use the managed services ranging from databases like MySQL, Oracle DB, to application services like WebLogic. And in cloud-native, you can build and deploy the containerized application on Kubernetes or deploy serverless. If you're running microservices applications in containers, you might want high performance, fast startup, and Polygot capabilities. Grail VM is an open source virtual machine that started in Sun Microsystems, and Oracle has continued supporting in its research and development. It is a multilingual virtual machine runtime engine that supports various languages like Java, JavaScript, Python, Ruby, Scala, Kotlin, R language, etc. Many companies like Twitter use components of Grail VM. For Java, it supports just-in-time compilers and ahead-of-time compilers for superior performance, and has therefore been adopted by frameworks such as Micronaut, Spring Boot, Helidon, and Quarkus. To give you an idea of the advantages of running Grail VM, here's an overview of performance in terms of memory footprint and startup time of Java applications. As you can see, both are orders of magnitude better. The reality of this is it translates to you having more time to do the fun things of development rather than waiting on slow performance and slow startup. What it means for businesses is higher development efficiency, faster iteration, and lower cloud costs because of its lower use of memory and CPUs. We've already touched on low code and developing, but as you can see, services go beyond and span 6 service domains: infrastructure, DevOps, applications, data management, analytics, governance, and security. As a developer, you get complete support over widely used tooling and frameworks in programming the services in OCI. OCI offers you REST APIs that use HTTPS requests and responses, software development kits for languages like Java, Ruby, Go, and Python, a command line interface that provides the same core functionality that a developer can use on the Cloud Console, Terraform, which is widely used by developers to program infrastructure as a code and is made available through the resource manager in OCI. This service allows you to define infrastructure resources in files that can persist, version, and be shared among team members. Ansible, another tool used widely by the developer community, allows you to automate the configuring and provisioning of cloud infrastructure, deploying and updating software assets, and orchestrating complex operational processes. A browser-based terminal named Cloud Shell, that is a Linux shell with pre-authenticated CLI, Ansible installation, and a few other useful tools, and Resource Manager, that helps to install, configure, and manage resources using the infrastructure as code model. So the tool set available to you as developers is extensive. So in summary, in our short time today, I hope I've imparted some of my passion for Oracle and the Oracle Cloud. I've outlined what Oracle Cloud OCI is. I've shown why Oracle Cloud is the programmable hyperspace cloud, and I've illustrated what it offers to you, to people who, in the words of our friend Leonardo da Vinci, happen to things. But let's not leave the adventure here. We want you to try Oracle Cloud for free. Since you're an attendee of GIDS, we are offering you an exclusive free trial. Before you visit the above link, make sure you stop by our virtual booth and register. By doing so, you'll receive almost twice the number of free credits. Additionally, if you'd like to get your hands dirty, make sure you attend Getting Started with Serverless Apps on Oracle Cloud Infrastructure later today. I encourage you all to take some time to explore, embark on perhaps a new adventure, and happen to things. I would now like to introduce you to two of my colleagues, Ali and Siva, who will help me answer your questions.
All right, the first question is from Panda Devashish, and so the question is about how is cloud native instant elasticity different from shaped clusters, and why should developers be excited about the converged approach Oracle is taking? So you can basically choose the shape of your clusters depending on your application type. For example, if your application is more memory intensive than CPU intensive, you can choose a shape that is more appropriate for that application, instead of incurring the cost of both CPU and memory with fixed shapes. Similarly, if you're more comfortable with working with fixed shapes or of CPU and memory, you can choose that too. The good thing is that in the Oracle Cloud, we give you the flexibility for both. And we are also taking a similar approach with load balancers in the sense that we give you flexible bandwidth as well. All this has significant cost benefits, which developers can enjoy, and you can program this kind of infrastructure as well.
Right. Thank you, Ali. There is another question. Let me read it out. Can you talk a bit about what in Oracle Apex application development will excite a data scientist like me? Well, as a data scientist, one could help designing the machine learning models and hosted them on a platform. For example, Oracle Autonomous Database helps in creating machine learning models from the data that is stored inside the database. So Oracle Apex can integrate with such machine learning models with the applications that are designed in Apex. For example, let me take one of the use cases that that could be easy to correlate. You have items catalog data and customers data in the database. A machine learning model is developed to predict the upselling potential of certain items in the catalog to the end customers. In the Apex application, probably we can draw a new column on the customer's dashboard that shows whether it is a good idea to try to upsell to this particular customer. Thank you.
Thanks, Siva. A third question from Raghav. Could you please articulate the pros and cons over the other major players such as AWS, Azure, and GCP? Well, I guess the pros I'll start with, in Oracle Cloud, it's secure by default in all the regions, including the dedicated region. All regions have the off-box virtualization on by default, and you don't have to reserve enclaves or pay extras, etc. We think security shouldn't come at a cost, and there's a big focus on it. You as a developer, you don't have to worry about if your object storage is public and such. That's the first one. The second is, cost performance benefits compared to the others, especially for database, compute, and networking. You've probably heard about, Zoom running their infrastructure on Oracle Cloud, and you don't need to sacrifice costs or performance to run your application. And then thirdly, in Oracle Cloud, we use well-known tools and technologies like Terraform and Ansible, which Alistair mentioned. But we're also using a lot of C and CF tools, for example, FluentD, Cloud Events, Kubernetes, among others. Now, these are the advantages, I would say. I guess for the disadvantage is that I guess we're not that well known yet for being a cloud company, but we are changing as a company, and we are improving on that image. And we hope to engage and collaborate more with developers. We have a GitHub page where we host a number of projects. You can engage with the Grail VM team or the Helidon team on Slack as well.
Right. There is one more fantastic question. The conventional wisdom is about how on-premises is fading. With all engineering effort focused more on the cloud, what is Oracle's take on on-premise And how do you see on-prem versus cloud debate evolve? Great. So most companies, as we know, are probably putting more effort in the cloud in some shape or form, and we are no stranger to that either. However, we don't see on-premise going away anytime soon. And we think what is important is to be able to provide customers two things: the choice of still being able to run on-premise if they choose to, and a path to migrate their different workloads to the cloud. So our journey continues.
Thank you for your questions.